Okay, and we are live. Hi, everybody. I'm Andrew, and this
Hi,
is
everybody. Oh, Carson's here. Carson's here too, interrupting.
no, all good. So yeah, today we decided, kind of with very little planning or forethought, um, that we would try a new kind of format to share with the community. We're both very interested in a lot of the research papers that come out. We don't find enough time to discuss them in depth. And so we thought we would do kind of a live read slash discussion of research paper. And so we've got a paper picked out. Let me go ahead and pull up my screen here. So this is from a few weeks ago. Kaggle put out this paper. You can go read it, called AI Competitions Provide the Gold Standard for Empirical Rigor in GenAI Evaluation. So we're going to get right into it. You can find the link on the tweet. I'll share the link in our chat on YouTube right here, right now. And feel free to follow along as we're kind of reading through this. We're going to do this in a kind of custom way. We thought it would be really fun to be able to highlight and actually discuss some of the key things, so you can really see what sections we're calling out as interesting. And so maybe we'll take a look at it. Maybe we can publish this Figma as something static later on in the YouTube comment or in the YouTube description. If I can figure out a way to do that, I'll share our annotations here for you. But yeah, we're just gonna move. I think we're just gonna move through it like kind of top to bottom and stop on some key sections. But I mean, first of all, broad reactions, Carson, to this paper.
Yeah. Yeah, so it's pretty nice. I mean, it's a position paper, so we're not expecting like full rigor of a fully peer-reviewed thing, but I mean, there's a bunch of stuff I really like about it. What I was really hoping for was like, a recipe for like this is why competitions are the thing.
Yeah.
There's a lot of things in here that I felt like they just I agreed with them, but they didn't provide the full, like I just agreed with them because I already agreed with them. It wasn't like they didn't fully give me the full argument for like why competitions and why leakage is a problem, blah blah blah. So I've got a few highlights in mind that I'm like, oh yeah, this is sort of making a big strong assumption here, a heroic assumption. But overall,
Yeah.
I mean, this is like a pretty great. I mean, if you look at like just even this first section here, like
we're just getting right into it.
This section here. Oops.
Yeah, I highlighted the same thing as kind of the first stopping point because I actually put it as like a marker for myself, like that the traditional ML evaluations are insufficient. And I wanted to make sure that this paper did two things. One, tell us what those traditional evaluations were, which I think they did a fine job of, and we'll get back to that. And then, yeah, get a little bit into the what's insufficient, which they definitely get into, but maybe that's part that's more lacking in your kind of upfront. I actually feel like this kind of paper, like this kind of exactly where it fits between sort of like a research survey or like field survey and like an analytical research paper. It's like a little bit in between. And I feel like I've written papers like this back in my old career where actually like the goal of it is almost just to introduce a point of view on the language and the framing of the problem. And then like maybe there would be follow-on research papers later. But yeah, why did you highlight this part?
Well, one is just a good example of like, they just say that it's insufficient. And I totally agree. But the kind of interesting thing to highlight here is they go into it right underneath here, right? Which is these are all the same reasons that we like competitions in general for humans as well. And actually, that was something I noticed throughout the whole paper. Like a lot of the arguments against like some of the existing, benchmarking systems and things like that are because like competitions are kind of like closer to real world, examples. They reflect the like fact that like from week to week, like behaviors and the outside world changes. And it's like, these are all effectively the exact same reasons we like competitions for people. It's the same reason we like competitions for agents. And if you think about it from that perspective, there's like, then the whole paper makes a lot of sense.
I kept kind of like, my mind kind of kept snapping back to human analogs and just that thinking of, if you want to evaluate how well, I guess, I don't actually know exactly what they evaluate, but if you throwing it out there, if you want to evaluate how well educated or the breadth of knowledge that like a high school student has, you might look at the SATs as one benchmark for that. And just thinking about the amount of resources and cost and energy go into rewriting that test every year and hiding it from everybody because they know the problem. If anybody could see what the answers were, then it blows up that ability to look at these kids with any kind of objective scoring. And you kind of see that play out again and again in here. But here you just kind of live in this world where these models are being trained on everything that they can possibly pull in online in structure. So yeah, the next thing that just worth calling out for me in the abstract was I was just looking out for this point that the problems of leakage and contamination are the most difficult and important issues in evaluating Gen AI. So all I just was doing mentally is saying, like, I wanted to learn more about their framing of that problem later on, which they definitely do. So we'll come back to it.
Yeah, I actually didn't know those terms ahead of time, but I had the paper in ChatGPT going at the same time, which is obviously what you have to do these days. And so that gives me a lot of good context there. Okay. Last thing I wanted to mention before, like in terms of like setup for the whole thing, maybe, is so I come from like an academic background, and I was in like do a lot of social science type questions. And so this kind of struck a chord with me right here, which is, okay, so we want to be able to evaluate these Gen AI models. And we need some way to evaluate them to be able to understand how good they are at particular tasks, especially as we're developing them. But it's really hard to actually evaluate them in any sort of like rigorous and comprehensive way. And they call that out here. Just like the analogy there is maybe like lab-based science versus like more observational science, right? Like these LLMs work best in the real world when they're solving like customer support issues or like summarizing and translating text and all that stuff. And it's very hard to like actually fully control for all the different factors, and like this leakage and contamination problem is like a good example of that. And so I like this analogy too, because basically we have to, their premise then maybe becomes something like we need to move from like lab-based science evaluation of these models to more like observation or like social science type evaluation of these models. And then when you do that, you're like, yeah, again, competitions start to make a lot more sense.
Yeah, can you actually go, in case I kind of feel like I understand pretty well what you're saying, but the wet lab piece of it, maybe can you explain a bit more that like challenge of like getting the objective data to perform a test and what the holdup is there?
Yeah, so basically, I mean, I think the biggest piece is, right, if you tie it back to this leakage and contamination process. Okay, so let's just maybe define that before we dive too much in. Leakage is when they end up training end up training the models on like previous outputs from those models. So you end up with like an example could be like leakage is when you include benchmark data in the actual training set for the AI agents, I think, right?
No. So contamination would be you train the models already knowing the inputs or like rough shape of these tests. Leakage would be more like there are other parameters of the data that tell you the answers, but don't mean that you knew how to derive the answers.
Right.
Yeah.
Yeah. Okay. So it's very hard if you're training these models on like, new data every time to actually create like sound and safe, leakage free and contamination free benchmarks in a way that you can like rigorously test them. And the big thing that they point out is like most of these like benchmarking testing frameworks that we've seen, they like make some fairly strong assumptions about the like environment within which they're being evaluated. So like they basically assume there is no leakage and contamination. They're that the like training data it comes from the same underlying distribution as the testing data, and like there's lots of these like very strong statistical assumptions that go into those building out those benchmarks. But the like reality is that when like agents are out in the world doing useful work, basically a bunch of those assumptions don't hold. So any of the benchmarks that we actually develop for them like don't really make much sense. And
yeah. There's actually, so moving here really quick, because there's a couple of things I was really excited reading this paper about, but I think are like maybe not the intent, but they're kind of there. So they make this bold text about basically the current state of evaluation is just insufficient for GenAI currently. But then the next one, I think, is actually, if you just jump to connecting it to this bolded point, the broader conception of generalization and GenAI. That's the piece I'm really excited about, because I've been talking about this a lot just in the last few weeks, that what these big foundation models are good at and known to be good at from the organizations that train them is like the narrow set of skills that training data leads you to believe they'd be good at, or post-training has guided them to be good at. But now in the world, there are all these industries trying to see, and I guess other point, we know that they oftentimes are very good at generalizing, meaning they've been trained for one thing, and that's taught them some skills that then they can apply to solve something that they've never been trained on. And that fact is kind of the strongest fact in the world, driving the world's economy right now, actually, which is like all these people, the world's AI economy is all these people and all these organizations are racing to see if these incredibly powerful models generalize to untapped domains of value. And the way they're doing that is, fine-tuning models or building programs or agents around models. And I think there's this like very strong theme in this, that in order to test all that long tail of generalized capabilities, we're actually need to produce environments that can test them faster and can have the certainty that all that information hasn't, contaminated the training, that we're not getting these artifacts that allow the leakage of the answers, like all these things. And it's really about this generalization of these models to, broad sets of skills. And I got really excited kind of reading that.
Yeah. I mean, it's cool because I think what we're like, we've kind of had this concept of generalization for a while in machine learning world, but it was more around like transfer learning, where like training them for some particular task makes them possibly pretty good at like a related or correlated task. And now we're sort of like, and in this paper they're proposing, we're way past that now. Like at this point, we're looking for like full generalization. And we just don't have, like, we have testing frameworks for looking at, transfer learning and like testing specific skills and like fine-tune models, but we just don't really have like a good way to evaluate like real generalized skills. And as a jack of all trades, master of none, I can sympathize with the models here a little bit.
Yeah, I just had this big note. It's about generalization, which is like an exciting framing. So the only thing else here I wanted to call out, if you got nothing else in this top piece, and before moving on, is just these two citations. They're just kind of, I love this in academic papers. They're kind of almost, they're so early on, such broad citations. The Dennett book is on consciousness, and the French guy Sculley, I assume you say it, is on the measures of intelligence. So it's kind of funny. I'd imagine those books aren't. Don't know.
I actually do. Book references are always funny because you're like, oh yeah, you should just read this entire book,
Yeah.
to help me make my single one sentence argument.
Also, just like the broad philosophical context of both of those problem areas. I think it's like so interesting to cite it. Anyway, okay.
Wait, before we move on to the next page, my favorite line in this whole thing, totally buy this, is this. And like in the open, like the peer-to-peer, like public networks world, this really resonates as well. This is a really important call out. I think it's like a kind of a big deal. Basically, the second you've like published an evaluation, that's it. It's like, you should consider that leaked. It's like out in the world. You can just basically assume every model will now be trained on that data.
Yeah.
Whether treated as like optimizing for that specific benchmark or evaluation, or like just as part of general internet data. And I think that's great because it's like you have to make those same assumptions in a peer-to-peer network. Like the second something happens and you've like given away control of that thing, you just assume it's like it's leaked or it's compromised in some way. And if you build systems around that, then I think you're building for a lot more robust system. So that was my favorite, like, because they've got this long thing. Like basically, we could just be like, oh, you want to know what happened in this paper? Just read section 1.1. But like, there's a few ones which are pretty useful, and that one I think is pretty.
Yeah, they did a good job bolding the key things to say there. But I did notice this in a few other places, that kind of that feeling of wanting some kind of more rigorous data in this paper, that there were places where it seemed to just be framing it for Kaggle being the solution, which is fine. I mean, it's part of them existing. But I thought, you need Kaggle to answer this need in a few places. But
although they did, maybe their reviewer was like, you know what, you should add like and similar platforms after Kaggle every time you write it. So they did.
Well, I'll just call out another one. The field should use established AI competitions platforms as a renewable stream of novel evaluation tasks.
Yeah,
I'm not sure. There are a couple of words I'd flag in that, because I'm not sure. But that side, I think it's totally fine. You see it all the time. What do you got there?
I also like this as a general concept. Basically, they're advocating for reproducible processes and procedures instead of like reproducible benchmarks, which is just driving home their sort of like concept around like competitions versus benchmarks. And like if your assumption is the second you release an eval, it's like compromised, then that basically makes benchmarks almost impossible to use, if that's your strong assumption. But you could have like a well-defined and immutable process that you apply every time, but the process itself drives like, it pulls in new data every time, or like generates new data every time, or like something else. And so you still can have like, fixed sort of like static things. You can just have like static static processes that generate new evaluations.
Yeah, so that then ends up being the majority of this, not the structure, but this next section. I mean, it basically just gives the background to that idea of, most of ML, since I've ever been involved in it, and I was looking at the dates of some of these citations, because I was first doing machine learning in the 2000s, and this was the standard, the test train split, and I thought it was just worth highlighting to people this like foundation for that, the independently and identically drawn from D, where D is your full sample pool. So that's been the paradigm. Like you basically, well, the paradigm I actually grew up with is the test train splits, as they later describe it, where you might be working on a problem and you'll upfront define your test and training split, and then you'll build your entire model. You'll do all of your training on the training set without any visibility into the test. And then what you do is you evaluate the quality of your model by running it against the test, where you have a new set of never before seen known answers. And then they say this is the cornerstone of the robustness setup.
Yeah.
Anything else to add there?
Well, one, first, I thought that this, like, it's a position paper, and it seems like they just had to sneak in a little bit of math. It seemed a little bit unnecessarily mathy in there, but
oh right, yeah.
It's like you could have just said training set. Anyway, whatever. But this whole section is man, it definitely brought back flashbacks. Like I'm thinking like a bunch of scikit learn stuff that I did where they have like automatic tools for like creating your train and test data.
Yeah, 100%. My mind went there exactly too. And like the day you first discovered that, and we're like,
I can automatically do it. Yeah. But the key take home for me, this whole section basically is saying, and I wrote it even down here. It's a whole section saying we train and test models by assuming that we have these like identically independent and identically distributed samples that are all drawn from the same like global population. But the funny thing about that, and like we literally state this whenever we like publish a paper or do research or whatever, we literally say, oh, we know that this is like probably not really the case in reality, right? Like the second our like models or agents hit the real world, like all that those assumptions almost go out the window. So that assumption that we're using to define the benchmarks are basically like, we know it's garbage, but we use them anyway because that's the only way we can like have the statistical rigor we need in the lab to like be able to say anything. And it's a little bit funny in that like it takes a position paper to actually be like, yeah, this is how we do it. But like the truth is so far from reality that maybe we should try to do, like, we should just be a little bit more honest about like what we're dealing with. So I thought that was kind of like, it was a good reminder. And so you can just like highlight stuff like this. Right?
Yeah.
It's great because it's the underpinning for like a lot of like the evaluations and statistical models that we use to like be able to say anything at all about the data. But, the very fact that that's the case means that is, this just often doesn't hold in practice. So it makes it hard to like deploy production models and have the same kind of confidence because that assumption doesn't really hold true. So it's just sort of like, anyway, a good reminder.
What did you think about this? This is the next piece I thought is just the first couple lines here of that flip from instead of independently, so up here, independently and identically drawn testing and training data from the pool. Instead of doing that for every new evaluation, you lock one in stone and you say that's the benchmark data set.
Yeah, so that was interesting because you read that and you're like, oh yeah, we do. We totally do that. We totally do that. And then you're like, yeah, I can't believe we do that. There's no way that's a good idea. But then you like scroll down and they actually have empirical evidence to show in this section, I think it's 2.2 here. They actually have, they're actually like, yeah, it turns out this doesn't seem to be a problem in terms of like actual generalization in the sense of like okay, if we assume that benchmarks are like a good way to do it, then like reusing the same test and training set to make it more reproducible seems to like not have an impact on the generalizability of the models within that like benchmarking framework. That I was a bit surprised at that, because I read the first one and I was like, yeah, it is a shortcut. We do it for like lots of reasons, partly because it's expensive to like calculate new samples, and partly because it makes it more reproducible. And then they're like, yeah, it turns out that shortcut is actually a great shortcut and it doesn't hurt that much.
Yeah, how much of that do you think comes down to the motives of the teams that are basically building models against public benchmarks? Because not many benchmarks have any like financial incentive or anything like that. I guess they'd have academic incentive if you train the next algorithm that's step function better than known algorithms, but it would only be against a benchmark, and everybody who tried to use it afterwards would realize the weakness.
Yeah, I mean, it's probably exactly what saves it. Like it's just like a handy trick. People use it, but like ultimately they're trying to do a really good job of generalizing models, because the outcome was my model is better than yours, and therefore you should read my paper and I should get a funding grant.
Yeah. But it also seems like, that kind of opens the Pandora's box here, right? Where like now we have these LLMs, which we're trying to train on the biggest set of structured data on the internet, which contains a lot of this data. And they're doing the model themselves are doing their best to learn the distribution of all this data. And it's kind of impossible to tell them not to overfit for these benchmarks, even if they might not have an objective to overfit for these benchmarks. Like,
right.
Yeah,
that's interesting. Yeah, I mean, we just know like we have less control, I guess, now over what the models are actually learning, because we just like it's just too massive and too complicated to.
Yeah.
Total aside, but like having these like pre-canned test and training sets. I remember like every single R package that came out always had like a baked in. Like, do you know, I played with this, I don't know what you call it, minced, like
MNIST, I always said, yeah.
MNIST, yeah. So much. Like I must have like played around with that test data set, like every image model until like last week has used this. I bet every LLM that has like image capabilities just has this like fully represented in the weights. Like
I think
never make a mistake on the MNIST problems.
We're in a bunch of the early TensorFlow like tutorial, like hello world things. We're like learning on MNIST data set too.
Totally. Yeah.
I think I remember that.
Yeah. Yeah. I bet like there's a bunch of these like, these like benchmark data sets that like all LLMs are like probably unreasonably good at like, generating the right response for it, or like predicting what letter is in there or whatever, just because there are benchmarks. And for this, like, you could never use
take it a step further. It's more than there just being a benchmark. It's actually all those repos and everything that teach you how to train for the benchmark. It's just what we just identified. They're like documented everywhere, exactly how to think about that data.
Total like related but separate aside, I bet, like every machine learning example out there, if you want to like control the seed for like the random number thing, it's almost always ends up being 42 as a reference to the Hitchhiker's Guide to the Galaxy. I bet you anything there's like an overweighting of numeric answers to the number 42 in a lot of the models, or they've all got like this number 42 in there, which is why Hitchhiker's Guide to the Galaxy is actually a predictive story of like when we start to ask these LLMs, they're just going to give us the answer 42 because 42 is in the training set so much. That's not a real question. You can just ignore that.
Yeah. Yeah, I was about to make a Canadian joke only because you're on the call, but something sarcasm 42. I don't know, but yeah, I was gonna go to the same spot here that you're highlighting because this is what we were talking about earlier. This is like what got me mostly like perk my ears up here, and I think it's a pretty interesting statement. That what we should care about in benchmarking or ranking or scoring GenAI is novelty-based generalization. So that is generalizing well to problems and tasks that have truly never been seen before by the system in training or development. Maybe, or if they've been seen, they haven't been explained. But yeah.
Yeah, I mean, this is obviously there's like core thesis here, I think. Makes a lot of sense.
Yeah. It almost is for me like a better title, instead of it being that competitions are the gold standard. It's this idea, and then how you solve for that is competitions potentially.
Yeah, that actually might be the framing I was missing in the position paper. Actually,
Yeah,
that might explain a bunch of it. It's just like competitions are one implementation of trying to get towards this actual goal.
Yeah,
might have been a good framing.
If the authors if this video ever makes it to the authors, they can comment. Did they think about making that a title?
Yeah, would have been a good one. Then that's if this is their like kind of core thesis, the follow-on paragraph, there's like a ton to unpack here. I mean, they even sort of like dive in to like more deeply sort of parse out this idea. Anyway, but it just drives home the point that like, solving the generalization problem is akin to like solving much bigger problems in AI. And so it's a good example of like, if you can nail this, if we can use competitions to get there, then like it actually is like akin to solving much deeper problems from a like more traditional ML benchmarking kind of perspective. Anyway, I just thought if you're gonna read something, read this. But I don't want to dive into it too deeply.
Really? Because I would go further because I actually thought the next paragraph was part of the must reads.
Okay.
Same deal. I thought it was just that part though.
Yeah. This is my favorite. I highlighted. I have this part highlighted. I like this dueling highlighting. Actually, this is kind of fun.
It is fun. Yeah, I like it too. We made up something novel.
And then you can continue, like take that part out, and then you just say, yeah, this. Yeah. This is kind of, yeah.
So what do you think? Because I guess we'll get into it later. They point out some benchmarks and skills that they test. I actually really love it. I guess we'll see this, and if I remember right in the paper, they're going to talk about some benchmarks. Sculley for coding. I forget the one that is like reasoning math, coding, language. It's kind of like the SAT of these models. And then they present their own Kaggle challenges as like these counter ideas, which are much more like specific skills that you're seeing if they generalize to. So we'll see. I don't remember exactly how they present this now.
We might have to come back to figure one in a little bit once we dive into that
up stuff. Here.
Yeah, because they talk about this kind of like style of sampling.
Mm-hmm.
And they talk about sort of like novelty-centric evaluations versus like benchmark style evaluations. Anyway.
Okay.
Okay. Yeah. So this page is where I wrote the most side notes in the margins.
You can drop them in as stickies too if highlighting isn't enough.
Yes. Oh, that just disappears. Anyway.
Yeah.
Well, we can probably just talk about them, but yeah, I mean, there's like I like this because I don't know, it's like bold statement. IID assumption is broken. Oh, that's a good question. And so Oh, I don't know. I just had some observations about this. I mean, it's kind of hard to argue, right? Like they just spent the bulk of the first part of this paper saying this. And then they just say like, well, then, so we really need to, we didn't even need to highlight this. They did it all for us.
Yeah, I did notice that a lot of my highlights they're bolds.
I wonder if that's a psychological thing.
I wonder if they
anyway,
ran it through GPT
like,
to tell them what to bold.
Yeah. If this is broken, then a novelty-centric way to like deal with this might be better. And if you slide back up to the paper, like they do represent it visually, which is kind of handy, where you imagine like, okay, instead of drawing random samples from your data set, you like specifically try to generate samples which like aren't really similar to any of the training data. And you could even like imagine like constraining it so that you can't create samples that are like very similar to original training data. And that's like, I think their point was not so much like you have to do exactly what we illustrated in this picture, but rather like we have to come up with ways to generate training data that is more novelty-centric and sort of just to avoid having to make this IID assumption in the first place. But I actually, so this is a little bit interesting, right? So because if you do that, you are sort of like, and we don't have to, I don't know, maybe I only briefly thought about this, but if you do that, you are also like introducing some statistical assumptions about your data samples. That if you do that too, right? Like you're purposefully like drawing samples that are not similar from your like original data, which means you're like biasing those samples in the first place. So you're like biasing towards generalizability instead of being particularly good at a single thing. So like in certain contexts, you might not really want that. You might want to train it like to be really good on a narrow set of problems and then have another one where you do sort of more generalized training. So I think you might not always want that, I guess. But if you're optimizing for generalizability, which they're sort of suggesting, then yeah, I guess you do.
Yeah, to me, it seems like the bulk of the investment right now is mostly around the single massive model that you're betting on the generalization, and then you improve the generalization by having it train smaller models or distillation into smaller models or post-training like techniques to get it closer. But like I think they're still squeezing a lot more value out of the biggest models that can generalize more.
Yeah, so you get these baseline generalist models and then you fine tune them afterwards. I mean, that makes sense too. Although then you're like, if that's true, then your sample for training is like basically all past internet-based text, right? Like it's all everything. So it's kind of hard to come up with like examples of testing data that isn't drawn from the sample of all. Like I gotta imagine that like at this point, if you look at all the text that's available on the internet, like we must have come pretty close to like, no, maybe I'm being crazy. But there's like, that's a lot of examples of like combinations of words and concepts in training. Like that's a lot of data. So it would be pretty hard to come up with some like at least language-based examples that fall like well outside of that.
I think there's a bunch of scientific ones that would be on Kaggle. I mean, the ones that we're going to talk about it, actually. They're going to give you the answer to that. The ones where you just don't even know the answer before the benchmark is run, and you either have to submit the model or submit your answers. So yeah, we'll get into that. And then your mind starts to open up that there's actually a ton of them.
Yeah, I mean, like temporally bounded things. But like, I don't know, if I say something about like the presidential election in 20, whatever the next one is, versus a bunch of conversations about the last presidential election, those are going to be pretty similar. Well, I don't know, actually, with current president, I bet there's lots of things that have never been said before. So maybe.
Well, so this was just the answer before, if people were following the what is leakage. And I think later on they give an example where they had a Kaggle competition. Yeah, it was the detect ET in a bunch of radio signals from space, and we don't have any signals of ET, so they just fed the data to the participants, and they introduced some fake ET signals.
Yeah.
But because they faked it, those ET signals had like hidden signal because of the way they were distributed. So that smart teams that realized that actually just modeled to find fake signals and therefore like could detect it. So that was a leakage where they weren't really detecting ET signals. They were detecting this secondary metadata that was fitting a distribution as if it was faked.
Yeah. Yeah. And then they have a bunch of other examples of these types of things. Like this, I think this one, this Nectar's, this section here actually reminds me a little bit of, do you remember when Google Flu came out?
Yeah. Yeah.
And everybody started like talking about Google Flu. So Google Flu is, for people listening, was like based on like analyzing people's search questions to try and identify like flu outbreaks. And it worked really well, like when it first came out. But then everybody started searching for Google Flu because everybody was so excited about how well it worked. And it totally destroyed the like quality of the model, because everybody started searching for flu, but they weren't searching like for flu symptoms or something. They were just searching for Google Flu. And Google Flu is like, basically, it just ended up saying that there's like flu outbreaks everywhere because everybody was talking about Google Flu. Anyway, that's always an example I thought was pretty good. We're pretty good at getting around stuff like that now, but
yeah. And then this is actually just evidence of what you were talking about 2 minutes ago, where they've already found that the test data sets on Kaggle are generally well known by every major model that they've tested, even if those models can't necessarily perform well on doing things with that data. Or sorry, no, they say it actually does. They can perform well, and benchmarks are related to that data, but doesn't necessarily mean they generalize to that domain or anything very well.
Right. Yeah, exactly. Yeah, they're good at solving that specific problem within that domain, but not maybe related problems within that domain, because they're not actually good at the problem. They're good at the data set. And then, so I don't know. Yeah, there's a couple of reasons I think why this is important. One is like it's misleading benchmarks and things like that. But the other one that kind of resonates with me is like, even philosophically, like if you're training these models and then they're generating outputs and things, and then generally, those outputs might be fed back in to create, synthetic data sets for like benchmarking or things like that. And then that gets like, slurped into the models, and you could end up with like information degradation and stuff like that over time as well, which I think is like also kind of not a nice outcome. You end up with like just slop models potentially. Anyway, so it's funny because it's not funny, but it's interesting because I wouldn't have like probably, conversations with machine learning people. I wouldn't necessarily have put leakage and contamination at the forefront of problems that must be addressed. And every good paper is like, oh, the problem I'm specifically addressing is the most important problem to address right now, obviously. But I was actually pretty convinced by the end of it. I was like, yeah, this is actually why competitions are great. Because
I mean, they're really well suited to make this connection, because actually the next section, exactly, it was pretty interesting. I was starting to look at these citations, and starting here on down, all of these citations for the next couple paragraphs, those are all actually Kaggle competitions. And so what they said previously was like, these models all know our test data that we publish on the site. They kind of already know a lot of these experiments that have been run on previous Kaggle competitions. So their team must be thinking a lot like, well, if we were to throw a new competition, how would these models do? And what they're saying is actually probably pretty bad if it has some of these properties that they'll get into. Yeah, and this is the SETI example.
Yeah. I highlighted this one too. Yeah.
Yeah, synthetically generated data was what they ended up figuring out how to detect. These were humans, not AI. These were human. Well, with the help of machine learning, they detected these as sort of the cheat code to detect ET in the system. What else you got here?
Okay. Well, so
this is your favorite. Bold.
Oh yeah, there you go. I also highlighted that one. And
okay, so then the difference. Okay, so now we're going to get into these ways of avoiding leakage. And should we just kind of go through? Oh yeah, if you're not ready, we can.
Yeah, we can. I highlighted that because I was like, well, if you read anything before this, you basically can't. This is an undeniable fact.
Yeah.
The paper. Yeah, I actually highlighted this section here, and I put a sad face. Because.
Yeah, so this is for people watching. This is maybe one of the more popular methods for. Or I would say it seemed like it was going to be one of the more popular approaches to evaluating and benchmarking LLMs, say a year or two ago, independently outside of the labs. So Scale AI, the ARC test. The ARC test, I don't know if it quite falls into this example, but this idea of holdouts so that the labs wouldn't actually train on the results. So it's kind of this. Yeah, this is definitely like ARC test is a little bit hybrid here, but the limitations are pretty hard to get around. So like one limitation is if you have holdout data sets that the labs can't see, the labs need to either ship you their model, or you need to be able to run, like the admins of the test need to be able to run it in some trusted environment or something like that. And so these just don't scale well.
Yeah.
So this is something that in our conversations internally a lot comes up, is like, if intelligence is really meant to proliferate, and we're really trying to figure out where these models generalize, and these models might be run in a lot of different applications and connected to different backends with access to different data and things like that, then these are never going to scale.
Yeah, that was my biggest take home here. That's why I did the sad face. It's like I just don't see a way to scale this to the level that we need for like continuous evaluations. Actually, before we go into this, well, yeah, this figure comes up again, but I basically just wrote 1,000 times yes on this figure. This is definitely where I want us to get to.
Yeah, pretty cool. Yeah, I think that comes a little bit later. So dynamic benchmarks. So the idea here being that you can imagine it like there's some test to the model, and the set of questions and answers in that test kind of continuously is moving in time. So no model that's trained now, by the time it's done finishing training, would have had the data that's in the answers in the model. Trying to avoid this. So yeah, live bench, this is just, the math, reasoning, language, coding. SWE, that's coding. So the way SWE works is like they curate a giant data set of GitHub issues. that then they're going to test the coding agents to see how well they perform on the issue. And the way they actually test it, if I remember correctly, they only consider issues that they have the PRs that close them, so they know the right answer in a way. So it's a really hard data set to curate, but you can kind of keep updating it and get the latest things. Yeah. And so this point that you're highlighting is just it. Like, even like the best coding agents today have access to the internet. So you're not really evaluating how good they are if you shut that off. And if you turn that on, then it's leakage.
Yeah, exactly. Yeah. And then I don't know, this also strikes me as like, I'm sure you can kind of try and control for this, but there's a possibility of like kind of drift as well, like in your data set, right? If, like a lot of them, they kind of have this like corpus of data, and then they kind of, actually, I think one of them, I think maybe, is it LiveBench? Yeah. So LiveBench like does dynamic benchmarking and a whole some holdout stuff as well for like the latest data. But it seems like there could be prone to like drift in the data in the benchmarking as well. But the biggest one I think is just that like the truth is coding agents have access to the internet because they should, and that kind of just induces leakage right away.
Okay, next way to do it, community benchmarks. So these are like, in a category of kind of human in the loop in a way. You match up the models to answer some problem, and then you just have a human tell you which answer is correct. And there's a few ways to configure that study. Yeah, go ahead.
This one's a little bit like hard to scale as well, right? Because you do that human in the loop thing. I also wondered how much of the novel test questions that come up are actually like synthetic data generated by models in order to like scale. Like how novel, I guess, are these like test questions actually?
Yeah, so that gets at their 2 points here, that these are difficult to build and maintain, and that the number of votes can be really large. So like the more things you want to evaluate, the number of votes is going to balloon. So pretty tricky. This part right here, tasks that require specialized knowledge do not scale to human rating. So if they need an expert, but this reminded me a lot of Vitalik's blog post on AI.
I had the exact same thought.
Yeah.
There's actually some pretty interesting like incentive mechanisms that you can use to draw out like expert opinions from crowds, which is quite interesting.
Yeah, so he talks about this. He just kind of categorizes these as two categories. One where you have humans just taking votes broadly and you can steer it by lots of people participating, or one where you have kind of these experts that have to give you the answers. But let's say you have a big domain, and you want to get the experts to give you all the answers so you can tell how well the model is generalized to the domain. You actually have the experts only do a subset of the answers, but the participants that are being evaluated don't know which subsets have known answers. They have to do it all. And then you basically just use the known answers to evaluate their quality. Probably all sorts of things to respond to in this section if you're on the Kaggle team about these scaling factors and what really works, though.
Totally. Yeah, I found this section really quite exciting because this is where actually the Web3 ecosystem has tools in place to like really help scale this.
But of course, what solves it all?
I don't know. Is it competitions?
Typified by
Kaggle. Yeah.
But it is. I mean, it's cool. AI competitions typified by platforms like Kaggle that can be embarrassingly parallel here. So by using the competitive framework and one thing here, this reminds me that we didn't bring up. One of the challenges of a lot of the previous sections is somebody's got to run that model. And if you're like fanning out the interactions with that model or the tests that you want to run, but you're not fanning out who actually runs the model, it makes it again, like it just adds this bottleneck of like cost or resources or whatever. Somebody's got to maintain actually evaluating all these models. And what they're saying is if you fan it out and you actually have the competition to not only evaluate them, but run the model, and you put that running the model into the as a responsibility of the competition participants, you can go embarrassingly parallel, kind of share the cost of evaluating a lot of these things.
Yeah, that seems pretty important, like pretty, maybe not obvious, but like pretty important for scaling.
There was one other thought in there. No, it totally left my mind, but Fridays.
Well, there's a couple more areas I think where like some of the insight from other areas of research and Web3 stuff could also apply. So maybe we'll find them. Maybe it'll pop back in your head. Here's another bold section.
Yeah,
so we should probably just highlight it.
Yeah, I mean, I like it.
Yeah, that's just driving home. Actually, one thing in the MEV, or sorry, in the Web3 world that I thought was kind of interesting is there could be, like, imagine you did this and you had this like sort of like, you know, you are running these competitions, you try to run them in parallel so that like no given model has like access to leaked data before another one. If that's not private, you know, if like it's like a public network, some of the stuff we've learned in Web3 around like MEV, like optimizations, so it might be like one model runs like a fraction of a second behind another one to see what their outputs are to like train on and stuff like that. There's some problems there that would have to be solved, but
yeah,
still pretty cool.
I didn't have anything else. So leak-proof competition structures. This perspective ground truth. So test set labels are completely unknown to the world during the active training phase of a competition. I forget. Oh yeah, this is actually a really cool example. I quite liked it. So the example they give is this function annotation challenge. So in proteins, you want to like map the structure and the folding of the protein to the to functional annotations, like what does it actually do? So what they did is they took a set of proteins that they hadn't they had the sequences, but they didn't have the annotations yet, which they know they know they can get by investing in the wet lab and doing the work. It's just very costly. So then all these participants didn't know the answers. They certainly couldn't have known the answers, and their models had to submit. Well, I don't know if they submitted their models or their predictions or both. And then only after that, they did the hard work in the wet lab to get the real annotations and then saw who won. Pretty cool.
Hard to scale that too, but pretty cool.
Yeah, and then the other one, the novel task generation. So generating novel tasks, novel tasks in which the test data doesn't resemble the training data. And so therefore more meaningful generalization. So yeah, you want to talk through that one?
I mean, I think it's another example of like objectively it's a good thing to do, but it does seem like for certain problem sets that's pretty hard. Like, you know, they're talking about like very targeted specific competitions where like you can get a bunch of mathematicians to come up with hard math problems. That's pretty tough to do at scale, although at some point we'll be able to get LLMs probably to generate math problems that they don't know the answers to.
Yeah, okay, and then this post deadline data collection. yeah, really similar to the perspective ground truth. Though you told me about a cool one from Ethereum the other day that just matches in this. I don't know.
Oh yeah. Yeah, I mean, yeah, it's perfect for that's exactly this. I actually wrote a little note here. This seems pretty scalable and very interesting. Yeah, I mean, well, it's I learned about it chatting with someone from the Ethereum Foundation, but in general, it's a big problem, I think, which is like trying to train models to predict whether a given tweet or
Tweets.
post is going to be community noted, is the term that they used, which of course is just a proxy for like is potentially misleading information.
Yeah, so this would be cool because you could create a long live always on challenge to have models that make that prediction, and there could be a parameter here, make those predictions as fast as possible. And then I think you said the like median flagging or noting time was like 6 minutes, but the half-life of a tweet or something like that is like 8, or maybe I haven't flipped. So the
Well,
problem statement here, yeah, the
yeah,
problem statement here is that the like flagging of tweets actually happens before all the spreading of the tweet is done, or after the spreading of the tweet is done. So could you move it faster?
yeah, it's actually on the order of hours. It's
Hmm.
like it takes hours to get a community note, and like by the time it's on there, yeah, like the most of the spreading that information is going to do has already been done. And
Yeah,
so
except for
even like
Grok.
15 minutes is like
Except for
pretty.
Grok, maybe Grok will know it's noted.
Yeah,
So
I
future AIs,
yeah,
yeah.
I must assume that like this is something that the like Twitter team and themselves are working on, but maybe not.
Okay, I mean, so that's pretty much it. I mean, conclusions in black, bold here. Move towards evergreen, repeatable processes. View AI competitions as a resource for AI evaluation, and adopt and improve anti-cheating structures from AI competitions to improve the standard practice. Any last thoughts on this stuff?
Well, yeah, this I marked up this page a bunch. Let's see if I can find them all. Yeah, I like this. 100% agree with this. I think it actually might be like one of the main arguments of the paper. Basically, any evaluations that you get should be viewed as like some point in time. Like at this point in time, this is what you can say, and nothing more and nothing less. And then if you think about it in that sense, then you kind of have to have like competitions all the time, actually, to keep evaluating and testing whether a model is good at what it says it's good at. Because otherwise, it could just have trained on like all the past examples. You'd be really good at reproducing. So I thought that was like kind of good. There's no competition here. Team Purple is
Everything could be made a competition if you care enough.
But actually, I wrote like I have tons of little sentences with exclamation marks on this page, because here's another one. I think they're really emphasizing the time component here, so I just wanted to drive that home. I think that's pretty key. You know, now of course they're Kaggle, so they're advocating in general for like a more curated, you know, like approach, because that makes sense. You want you want to be the like arbitrator of like what is good. They also talk about having like ELO side by side sort of like ranking style things like LM Arena, which I resonate. I think that's really smart. Like, I don't care specifically like how good an agent was at like a coding challenge maybe like it got 75 or 35%, but I do care like if it's better than other ones at some particular task. So like having
maybe worth we talk about ELO ranking a few times a week. Recall, maybe explain that one to folks that might still be listening.
Yeah. They're all still listening. There's more now. I'm sure of it. Yeah. So ELO scoring. Well, ELO comes out of like chess scoring chess players, but it's basically a way to come up with sort of like reasonably objective relative metric for how well a given player performs against others. And then there are various versions of this for measuring like broadly skill, in some of them, like in multiplayer games, and ELO is more of like a one-on-one, like two, face off against two players against each other, or you can do like combinations of them. But anyway, the whole point of all these different scoring systems is basically to be able to produce rankings between players that applies over time, even if like at any given time those two players aren't playing against each other. And it gives you a sense of like who the top ranked person is, and down from there. And so in a lot of cases, we just want like a relative measure of how good someone is relative to everybody else versus like what the raw score was for a game or a benchmark or something like that. Yeah, we can keep going on. This section is like, okay, we should adopt and improve on anti-cheating structures from AI competitions to improve standard practice. Like that's obviously clearly a good idea. And they mentioned like as a field, we should move forward and learn from the best practices that like we've had to develop as Kaggle or other competitions. Like we had to kind of adapt and build some best practices around competitions. One of the cool things here is because competitions are like real live experiments with like money on the line. So people just trying to find all of the shortcuts that they can possibly find, because the goal, in a competition framework is like to win the competition. So you want to win that competition however you can. It doesn't necessarily always lead to like, building the best general model for that particular problem, right? People are trying to optimize for the like task at hand. In this case, it's winning the competition, not necessarily being the best at the thing that the competition is measuring. And this is something we deal with in Web3. Like literally, this is the main reason we spend a lot of time thinking about mechanism design, because they operate like on public networks with like permissionless participation and all this stuff. So we have to build tools to make sure that like everybody is aligned with the goal of the competition or the goal of the network. So I don't know. I thought it was good. Is like we should learn from best practices developed in AI competitions, but maybe like also other industries, like Web3, where we're dealing with this all the time.
A couple of things here. One, that came up in a call the other day with one of our colleagues, Derek. We were talking about Goodhart's law. So in an organization, once you start to measure and build goals around a metric, it makes that metric more or less useless.
Yeah.
So pretty interesting. Same thing here. I also thought that this last point in the last paragraph, that there's this reasonable viewpoint that none of this matters, because these academic evaluations of GenAI no longer can match just this performance in the real world, which you should be able to measure by economic impact, how many people are paying and using them, things like that. Yep. I think there's some interesting balance here. What I've said before is like when we've been looking for this in teams that are trying to generalize to crypto trading, that's a really clear one where the market should be easy to point to the winner. But in these early markets, a lot of times the information and the utility is discovered a lot faster than financial market can identify it. So you might have teams that have less awareness, less brand, that are actually solving problems better than those that have a bigger brand and bigger reach. And the market is going to go for the latter generally early on. So just how do you create these like neutral playing fields and actually evaluate them until the market shows up and can do it?
I mean, that's the beauty of competitions. That's what they're really good at.
I mean, it is kind of what happens coming out of any education, where you want to know, sure, the best way to know what students are going to do the best in my university is going to just enroll them and see who does the best. But you want to figure out who, like when there's that giant pool of students, you want to filter them early until you can get stronger signals later. But yeah, I don't know. Overall, I'd say 7 out of 10 paper. Like maybe higher. I'd give like 8 out of 10 because strikes a lot of chords as far as interest areas, helps articulate a few different problems that I've been trying to articulate, just like intuiting, but they do a good job putting their position on it. Makes sense. I don't know. What do you think?
Yeah, I was gonna say about a 7. I mean, I'm gonna add this to my like toolbox of evidence for some, in argumentation. I think it's pretty good for that. It's kind of also, we find ourselves agreeing a bunch, and like at Recall, we spend a lot of time thinking about a lot of these same problems. So it's nice to get, some smart people agreeing with you.
For us, it's like really about how do you do this, also do this, do this.
Yeah.
And we're kind of trying to put a leg in both columns here. One being the practical use of competitions, and the second being how do we create systems of scoring or measuring, and how do we reach out into domains where they don't really need the academic test, but we can still measure their quality and get that information to users.
Yeah, exactly. I think we're in the right domain. There's like, I find myself just going like, oh man, there's so much like, so crypto economic incentive structured things that help address like all of these bits and pieces.
Yeah. Cool. Anyway. Well, I don't know if anybody listened, but it was a fun conversation and it forced us to talk about a paper. So we should do it again.
Yeah. I like the dueling highlighting. I'd do that again.
Yeah.
It also just forced me to read a paper this week, which is a good thing to do as well.
Exactly. All right, cool. Thanks everybody who tagged along, and thanks for some of the comments here. Lots of positivity, a lot of good vibes out there. So that's cool. Have a great weekend.
Sweet. Cheers.